This video demonstrates mipmapping and texture filtering in OpenGL as a part of my assignment for CS7GV3 real-time rendering. All textures are generated procedurally at a resolution of 512 into 512, and after creating them, I call the glGenerateMipMap function to build the full mipmap pyramid automatically, which gives me pre-filtered versions of the same image at half a resolution, such as 256 into 256, and then a quarter of the resolution, which is 128 into 128, and so on down to 1 by 1. When I zoom the camera in so a texel covers many pixels, that's magnification, which helps avoid the appearance of blocky texels. When I zoom out so many texels compete for a single pixel, that's minification, in which case aliasing and shimmering appear on the textures if we don't use filtering and mipmaps. In the UI, I can switch between different filtering modes: discrete, nearest neighbor, bilinear, trilinear, and their filtering mipmap variants, as well as optional level of detail bias. Nearest neighbor sampling picks the closest texel per pixel. It's fast but produces blocky squares during magnification and aliasing and shimmer during minification. Bilinear filtering samples the 4 neighboring texels and linearly interpolates between them, removing blockiness during magnification and softening the edges of texels. With mipmaps enabled, linear or discrete mipmaps select a single pre-filtered mipmap level and apply bilinear filtering within it, which already reduces aliasing significantly at a distance. Trilinear filtering goes one step ahead by blending bilinearly between 2 adjacent mip levels as well, and then gives a smooth transition across distances without visible banding at level boundaries. Finally, the optional LOD bias, or the level of detail bias, shifts which MIP level the GPU prefers. A negative bias favors high resolution levels with a sharper look, and a positive bias favors low resolution levels for a more stable blurred result.